What is up, Algebra 1 students? This is lesson 53. Our objective is how do you add and subtract polynomials? Before we talk about adding and subtracting though, let's talk about just the basics and terminology we use when working with polynomials. Before we talk about polynomials, let's talk about a monomial or a monomial. A monomial is simply the product of numbers and variables. So maybe some examples of some monomials, it would be like, supposed to be a 3x, or maybe 17x squared yzq. Those are monomials because everything in there is multiplying. These over here are not monomials. Whenever you have x's on the denominator or variables on the denominator or inside radicals or with negative exponents, it's a negative 7 right there by the way, then those are not a monomial. Okay? A binomial is just the sum of two monomials. So an example of that would maybe be like x plus y, or maybe 3xyz plus 7. Those are examples of binomials, because that prefix bi means two. On that basis, a trinomial is a sum of three of them, maybe x squared plus 2x plus 7. Or x plus y plus z. It's a trinomial. And then anything that has more than three terms, like if there's 4 or 5 or 10 of them, then we call it a polynomial. And technically all of these are also polynomials. Polynomial is like a broad term, like saying a vehicle. This is a truck, a van, and a car. But they're all vehicles. So these are all polynomials, but when they have just one term, two terms, or three terms, we call them monomials, binomials, or trinomials. And then we normally use polynomials for more than three. Alright, so now we didn't talk about names, let's talking about describing them. The degree of a polynomial, that's not how good they are at karate, or how long they've been in school, but it talks about the sum of the exponents of the variables. So if you come in here and look at this, the variable on that x is a 2, and the variable on the y is just a 1. If it's not written, it's a 1. So the degree of this one is 2 plus 1, which is 3. So the degree is 3. On this next one, the degree of this one is 1, the degree of that one is 1, the degree of that one is 1. And notice, don't be tricked, that 2 has an exponent of 7. But it's just the sum of the variable exponents. So the degree of this one is going to be 1 plus 1 plus 1, which happens to be 3 again. Okay? And the degree of this one, well, there are no exponents, or there are no variables, so if you want to, you could think of that as x to the 0th, because remember, x to the 0th is equal to 1. So the degree of this one, we'd say, is 0, if it's just a constant, right? Or, if we had a d here, and it was just like 7, again the degree would be 0. When we talk about the degree of a polynomial, we talk about the degree of the greatest term. So notice here we have 1, 2, 3 terms. The degree of this first one is just simply 2. This one is 3 plus 1 more, so the degree of that one is 4. The degree of this one is 1, so the degree of this polynomial would be 4, because that's the term with the highest degree. This one here is 1, 1, 1, so the degree of that one is 3. The degree of this one is 2 plus 1, so that one is 3. The degree of this one is 1 plus 1 plus 2, so that would be 4, so the degree of this one would be 4. Now the leading coefficient is the coefficient or the number next to the term with the greatest degree. So we already determined which one has the greatest degree, right? This one and that one. So for part A, the number in front there, oh, you know what? And I was misleading there on that part A, because that's a 4 to the third power. 4 to the third power. So that means the degree of that one is really just, I thought it was a y. Can't even read my own handwriting. So the degree of this one is not 4. I apologize. The degree of this one is going to be 2. Because the degree of this one is not 4, but just simply 1. So this one's 1, this one's 1, that one's 2. So the degree of that one is 2. Let's look at that one then. The coefficient of the number next to it, since there's no number written, is going to be a 1. So for A, the leading coefficient of that is 1. And similarly there in part B, there's no number written, so it's a 1 there. But if there had been like a 7, then, or a -2, then that's what would have been the leading coefficient. And we'll talk about that more as we do more examples. Standard form is whenever you write each term with decreasing degree. So if we look at that first one, notice this first one has a degree of 2, this one has a degree of 1, that one has a degree of 1. So this one's actually already written in standard form. X squared plus 4 cubed y minus z, or you could have also written that x squared minus z plus 4 cubed y. But normally when there's a tie, then we go alphabetical by letters, so normally we'd probably write it this way. But either one of those would give it to you correct. This one has a degree of 4, this one has a degree of 3, that one has a degree of 3. So this one is going to be x, y, z squared. And then plus, you can choose either one since they both have degree 3. I'll just go x, y, z plus x squared y. And that's written in standard form, so because the degree decreases as you move from left to right. Alright, so now let's get to adding and subtracting them. When you add and subtract, you just line up the like terms, or the ones that have the variables that match exactly, and you add those together. So for this first one here, I'm going to rewrite underneath. So this is going to be an x squared plus 4, because notice I don't have any x's in there, so there's not going to be any here. If I want to say plus 0x. And then just add. 8 plus 4 is 12. 1 plus 0, right, the coefficient there is 1. 1 plus, so it's just going to be x again. And then 2x squared plus another x squared is going to give me 3x squared. So just add those coefficients. This one is maybe a little bit more tricky here. This is going to be, oh, and it says write in standard form. And this one does happen to be in standard form because this is, the degree of this term is 2, the degree of this one is 1, the degree of this one is 0. So it's in descending order. For this next one here, let's go ahead and write this one in standard form. 3x squared plus x plus 10. And then as I write this one underneath it, I'm just going to write them underneath, or where they would belong in that. So 4x squared, so this is going to be 4x squared, minus x cubed, so that's a degree higher, minus x cubed, plus 3x, minus 9. Then just add down. 10 plus -9, or 10 minus 9 is going to give me 1. X plus 3x is going to give me 4x. 3x squared plus 4x squared is going to give me 7x squared. And then I don't have anything up here, so it's going to be -x cubed plus that. And notice that is in descending order because the degree is this 3, degree that's 2, degree that's 1, degree that's 0. Now subtract is pretty similar to adding, except for you have to switch the sign of all of these. And if you want to think of it this way, this is kind of how I think about it. I think of this as saying plus a -1 times that whole mess. And so then I distribute in that -1 and then end up just adding. So this first one stays positive. So I'm going to say 12y cubed. And then I'm going to leave some space. I'm going to say plus 10. I left some space because I don't have any y squareds or just y's, but I do see some down here. Okay. So now I'm going to write the second one here that's in blue. This is going to be minus 18 y cubes, right? Because I took this negative and distributed it in, so that's a negative. Became positive, and this became negative. So plus 3y squared minus 5. Now when we add 10 minus 5, it's 5, 3y squared, and then that was going to give me -6y cubed. Again, this is in standard form because it's y cubed, y squared, and then, so it's degree 3, degree 2, and then degree 0. One more here. I'm going to do this one just slightly different, but still same concept here. Rewrite this as x squared plus 4x minus 9 plus, distribute in that negative, minus 4x squared plus 5x minus 11. Now I've changed that negative to a plus, and I can just add like I did earlier. So this is going to be x squared plus 4x minus 9 minus 4x squared plus 5x minus 11. So adding these two, since they have the same sign, is going to give me negative 20. Same sign, so you just add. Same idea here. 4 plus 5 is going to give me 9x. Same sign, so I just add. This coefficient is 1, so minus 4. So 1 minus 4 is going to give me negative 3x squared plus. Alright, your homework is down here on page 339. You're going to do the lesson practice, all the 53s and all the 52s, but you don't have to do any extra beyond that. Good luck. Feel free to watch again as you need.